Let us solve a problem based on logarithms. So the problem statement says that if a is equal to log 5 base 4 and b is equal to log 6 base 5, then log 2 base 3 is given as 1 by n times ab minus 1, where n is some integer. You need to figure out the value of n. So here if you observe, this is a and b. So let's multiply a and b. So before proceeding with solution, I would suggest you that you pause the video and try it on your own. Alright, so I hope that you have tried by yourself. Now let's proceed ahead. So we can just multiply a times b, that is your log 5 base 4 times log 6 base 5 here. Right, now we can apply this property here, that is your log of n power p base a power q. So that is equal to p by q times log of n base a. So you can see n power p. So this p is in the numerator here, and this a power q, this q is in the denominator. So we'll use this property for this one. So now I'll be writing here ab as, so I'll write ab as, so this 4 can be written as 2 square, right? 2 square. And if you apply this property, here, so we can write here 1 by 2. Why? Because you have 5 power 1 here and here 2 square. So that is your 1 by 2. And this can be written as log 5. So here we can write log 5 base 2 times log of 6 base 5. Now proceeding ahead. So again this, I'm just writing this expression. Okay, I'm just continuing this expression. Now if you see, you have something called log 5 base 2 here and here log 6 base 5 here, right? So we can apply one more property, that is the base change theorem. Okay, so whenever you have log b base a, you can just take a defined base, intermediate base, and you can just break it down like this. So here log a base b is there, so you can take a log base of your choice according to the situation of the problem, and then you can just split this apart like this into numerator and denominator, right? So this is the property which I'm going to use now. So I'll be using this now in this expression. So this one I'll write as it is, and here I'll just break it down according to this property. Okay, base change theorem. So now what I will do, I'll write here natural log of 5 divided by natural log of 2, and similarly this one, natural log of 6 by natural log of 5. Okay, so natural log of 6 by natural log of 5. So you can see this, that this natural log of 5 will cancel, right? So this will cancel out with this one. Okay, so after the cancellation, again if you just merge this natural log of 6 by natural log of 2, so this will become log 6 base 2, right? So this can be written as half times log 6. Okay, log 6 base 2, log 6 base 2. So finally we have this expression. Now we'll break it further. We can split this fact, okay, further apart. Now this is nothing but, this one can be written as 6 can be written as 2 times 3. 6 can be written as 2 times 3. So this will be 2 times 3. Now again we will apply the property of product and sum. So product and sum is this one. Okay, that is your log of m times n, and if the base is same, base is a, then this product can be split into sum and vice versa. So we'll use this property now. So let's use this property. So we'll be using, now I'll write using this property. Okay, so this one further I can write using the property. This one is equal to half times, in parenthesis I'll be writing log base 2 and argument 2, right, plus log 3 base 2, again log 3 base 2. So that is it. Now if you notice here, log 2 base 2, right, so this will be 1 again by this property, that is log of same number and base same number, given the condition that the log is defined, the answer is 1. Now this becomes your 1. So further this expression I can write here instead of this log 2 base 2 I can write simply 1. Now what I need in this expression, so here we have log 2 base 3, so we need to get log 2 base 3 out of this expression. So finally what we have AB is equal to this expression, right? AB is equal to this expression. So I'll be writing it here. This becomes 2 times AB is equal to 1 plus log 3 and here base 2, isn't it? So I hope the story is clear till now what is happening. And now this one can be written as, so we can just isolate this log 3 base 2. So we can write here log 3 and base 2. Log 3 base 2 can be written as now 2 times AB minus 1, right? So here n times AB structure is available. Now what we can do, we can take reciprocal both sides. So this will become 1 by log 3 base 2, 1 by log 3 log base 2 and argument is 3, and this will be your 1 by 2AB, okay, minus 1. Now this will be, so this one I can write, this one again I can apply a property, that is this one. So if you have this one, right, this property we can apply. So using this property, so how does it works? We can write this one as, if you have something like this, let's say log a base b, right? If you are having log a base b, so let's isolate this log a base b. So if you want to isolate this log a base b, this becomes your 1 by log b base a. So you can see that after reciprocal, this argument and the base exchanges over here. So here argument is a and base is b, and here argument is b and base is a. So after applying this reciprocal property, so this will become you will get the desired expression, that is your log 2 base 3 equal to this. Okay, if you compare the expression, so n is 2. If you check here, okay, if you check the expression with this one, that is your log 2 base 3 is equal to 1 by n times AB. So here n, so 2 is the integer that is required. So finally the answer is 2. I hope that you liked it. Answer is 2. Okay, so please comment below that what is your opinion about the steps. If you are having something better than this, please do comment so that others can take benefit of your comment, right? Okay, thank you.